Okay, we're here for the Math 2460 Zoom meeting. And yes, we welcome, I saw your names there briefly. We got 5 other participants here because I'm one of them. 6 total. Did y'all want to see anything in particular today?
Could we maybe do some of the WebAssigns?
If you can feed them to me. Yeah, I learned, going over trying to draw up WebAssign that, it scrambles the problem. So if I draw it up, it's probably not the same problem as the one you're seeing. So can you feed it to me?
Yeah, let's just do this one because it has everything. It's use Scheller disk method. So it's y equals 10 over x squared.
Okay.
Then y equals 0.
Okay, that'd be the x-axis.
Yeah, x equals 1 and x equals 5.
X equals 5. What axis are we going around?
It's the x-axis, the y-axis, and y equals 10.
Okay, so they gave you 3 separate problems.
Yeah.
Okay, so this is from WebAssign.
Question 5.
Okay.
Well, for me.
Yeah, for you, it's question. Yeah, that's the other thing that I hate.
I think it's right. I think that everybody has that question 5.
Right.
It's just there's a couple numbers. So like it has the number 10 and the number 5 highlighted for me, and I'm pretty sure that's what's like switched. It's just like same problem but slightly different numbers.
Yeah, that's the other thing I should think about when I'm going through my version of WebAssign and say, yeah, that's a good problem. That's a good problem. Do 1, 3, 5, 6. I tend to forget that you're not getting exactly those same problems. And so I'm hoping you can still do them even if they've changed the numbers or whatever on them. Okay, so this is volume, and what was the first one? X-axis, just to keep in the order you had it.
Yeah, it was X.
I don't know if they called it part A, but we'll call it the X-axis, or we're going around. X-axis. All right, I'll just write them over here. B, Y-axis, and C was, you said Y equal 10?
Yeah.
Okay. So when I see function of X around the X-axis, I'm thinking washers. So I would plug and chug into pi integral a to b f of x g of x dx. I don't hardly need a graph, but if you want to see a graph, if I had 2 curves, I'd definitely do a graph because I don't know which one's top and which one's bottom. But with the x-axis, it's pretty clear the f is just the top. But quick graph. Okay, clear 10 divided by x squared. Window. I'll go back to negative 10, 10, and graph. Okay, so I'm getting 2 graphs that have the x, or 2 curves on it that have the x and y axes as asymptotes. And let's see, I'm really going from 1 out to 5. So I'm really only on the right side between 1 and 5. And I'm going around the x-axis. So yeah, f is clearly the top. This is the f, g is 0. So plugging in pi, I'd be going from 1 to 5. 10 over x squared quantity squared, if you want to be really complete, minus 0 squared dx. Do you need help punching that in?
No, I should be fine with that. The X one's definitely the easiest. I think the Y and the around a line are hardest.
Okay. So B around the y-axis, that's going to switch me to shell method. Function of x around the y-axis. So I'm going to switch to 2 pi a to b x f of x minus g of x dx. 2 pi, 1 to 5, x. The f of x is 10 over x squared minus the g is 0 dx. Did that go too fast? You can punch
I
it
just
easy.
think I'm bad. No, because like that was extremely easy. For some reason, I struggled with it last night. I was probably just tired.
Yeah, that's fine. All right, you wanna see this punched in, or you want to go on to the y equals 10?
Yeah, let's do the around the line, or the 10. Yeah.
Y equals 10. I can use this diagram up here. I can redraw it. I'm really just doing this side between 1 and 5. This is 10 over x squared up around y equal 10. So now I'm back to washers because I'm back to a horizontal axis. So we'll call this part C around y equal 10. Not 110. 10. Okay. I'm going to use this formula, pi integral a to b outer radius squared minus inner radius squared dx. The outer radius is going to be really easy here. Our outer will just equal 10. It's a distance of 10 from that axis down to the x-axis. All right, the inner radius, that will be, if you can see it, remember up, it's y, 10 minus y. But I got to convert that. 10 minus y is 10 over x squared. So if you want it by itself, the inner radius is 10 minus 10 over x squared. I got just enough room to plug it in. I'm going from 1 to 5. 10 squared minus 10 divided by x squared, quantity squared, dx. That keeps functions of x going around a horizontal axis. I could do the shell method, but it would switch everything to y, and I'd have to switch and solve this for x. And you can play it that way. If you want to see it done that way, I'll be happy to set it up for you that way.
Nah, I think this way is definitely probably easier. I think the big thing that I was messing up is the r equals 10 minus y, and then you replaced y for the function. I just think that I didn't understand. I didn't like connect that last night.
Okay.
Yeah. Okay. Thank you.
Sure thing. Okay, anybody want to see any other problems worked? We're up to 6 other participants coming out early on a Friday morning. Appreciate y'all coming out.
Maybe we can touch on some the 7.4 unit because we didn't touch on that last time. So the
That's right. Okay,
yeah
so you
the
want
arc
right.
length and whatever the other one is, the surface area.
Okay. Why don't we charge into arc length?
Yay, another formula.
Yeah, you're going to be buried in formulas by the time we finish 7.4. It's called arc length. Okay. Real quick derivation of where this comes from. You really start with the exact same diagram from the beginning. It's amazing how many things we're calculating off this same picture. Area underneath between an A and a B. Area underneath, volume swung around the X or Y axis, etc. This arc length is the length along f of x from here to here between A and B. And B. Okay, and the very first thing we do is we give up, because the only thing we really know about length and arc length of a line, or is length of a line. Anybody remember college algebra distance formula? This look familiar? X2 minus x1 squared minus y1 squared, and that forms the length of a line between x1 and y1 and x2 and y2. It's the only really formula for distance we have. But unfortunately, Newton didn't give up. So what he did is, since we only know how to do lengths of straight lines, I'll exaggerate it a little bit. He formed lengths of straight lines along the curve. So the idea is to bust it into individual straight lines between an A and a B. And then, of course, to add up the individual lines and take the limit as you shorten the lines. And it conforms, as you make the line shorter and shorter in the limit, you conform to the actual curve and get the direct, exact arc length you want. So how he did that, take, say, a segment, we can call the forward length delta x, call the vertical you go up delta y, make it a right triangle. I think he calls the arc length, I guess I'll use L for arc length. Can you see you got a Pythagorean theorem situation? L squared would be delta x plus delta y squared. Have we lost anybody? Okay. L squared then, factor out the delta x. Now that's a neat, I'll write that down, factor out delta x. Now that's a real neat trick, because it's not a common factor. But the way it works, hold it in front, big parentheses, stick a 1, because this times 1 is this. Now there's no delta x to factor out here. Oh my goodness, oh no, what am I going to do? Well, it works if you divide this by the delta x. So everybody see that it's a correct factoring. This times 1 is this. This times this would cancel the delta x squared, and you'd still be left with this. Let's throw the delta x squared to the back. Collect this as one entity, all squared. Delta x squared at the back. Take square root. And you get a big square root, 1 plus delta y over delta x. And then this is a perfect root, just a delta x at the back. And now you start, this was the first line segment. You start bringing in Riemann sums, adding up all the individual segments. This delta y over delta x goes to the derivative dy dx, or they usually use f prime of x. And this becomes your dx. And you wind up with, this is what you should remember. Your arc length is an integral from a to b. Big square root, 1 plus f prime of x, quantity squared, and dx. That's the arc length formula, plug and chug. they're going to give you the general function form, but it does not go directly in. Its derivative does. Formula for arc length. Are you ready for some homework examples?
Professor C, do you think we need to remember this formula?
Oh yeah, you definitely need to remember this formula. That's just the first formula of this section. You want to try some homework on page 481?
Sure.
Okay. We'll start, say, down with number 7 there. You don't really, they gave you the picture, you don't really even need it. So further down, when you start with some other ones, like at 11, they quit giving you pictures at problem 11. Oops. Problem 11, they quit giving you the pictures. Oh, where's it? I'm knocking my camera all over the place. But at problem 11, they quit giving you the graphs, and that's okay. You don't even need them. And you know, I knocked my camera back to the narrow mode. It stinks. I did not mean to do that. Now I'm all, let's see. Instead, I could go back. Let's see if that's straight. Yeah, that straightens it out, but I'm on narrow mode. I'll have to write bigger unless I stop the share and reset it. I guess I'll just write bigger. Okay, so try page 481. Number 7, y equals 2/3 plus 1 raised to the 3/2. Off the graph, you can see it's running between 0 and 1. When they don't give you the graph, they'll give you the interval that you want it over, and you can see it's running from here up to here, 0 to 1. It's a straight plug and chug. Your arc length would equal, you'd have the integral from 0 to 1. Square root 1 plus, I'll keep it f prime of x squared dx. You can call this f of x if you want, or y prime. In any case, I need a derivative of that. My f prime, you'd have the 2/3, bring down the 3/2, x squared plus 1 raised to the 1/2, because you'd subtract 1. Look inside, and your chain rule is 2x. Your 3's cancel, 2's cancel at the front. And this is what will plug in. I just go ahead and plug this in for f prime. So my arc length will be integral from 0 to 1, big square root, 1 plus, big parentheses, x squared plus 1 raised to the 1/2 times 2x, big parentheses, squared dx. These are going to tend to, although it's a simple looking formula, are going to tend, because of the derivative here and squaring it, going to tend to give you some complicated entries. Can y'all read that, or should I reset the camera? Not getting any response. Is it worth it to take time to stop and reset the cameras? Not getting any response. I can't hear y'all. Y'all so amazed that you're. Are y'all still here?
Yeah, wait, what was the question? I went and got a muffin.
Oh, hey, you don't have no problem. We picked up another participant here. You got 6 people on with us. Is it worth it to stop the camera and go back to the wide zoom? Or can y'all read?
I personally can read it. If anybody else has a problem, they can say something, I guess.
Anybody want to see this punched in?
It's just punching into the calculator.
Right, okay. So I don't have the answers in front of me. They're in the back of the book, but you should get it. Anybody want to see 13 will probably be a pretty nasty punch. You want to see that one punched in or set up?
Sure.
So we're on page 481. This is 13. X to the 5th divided by 10. Add 1 over 6x cubed. And they're telling you they're going between 2 and 5. Yeah, the nice thing about these, even though they do lead to nasty punches, is that you don't really need a graph. It's straight plug and chug. I'll write the formula, integral a to b, big square root. I'll just use y prime squared dx. As they call this y, I'll call the derivative y prime. Whatever curve they give you, your derivative goes in squared. So that's the trick to these things, is getting the correct derivative. Hope y'all remember all your derivative rules. Well, you can keep the over 10. You'd have 5x to the 4th. You'd have 1 6. And you'd have 3x squared. If you want to plug it in exactly, help yourself. If you want to reduce your fractions, they're both a half. 3 to 6 twice, so you really have 1/2 4th plus 1/2 x squared. So when you plug in integral from 2 to 5, yeah, they're giving you the a and b there. Big square root 1 plus parentheses 1/2 x to the 4th plus 1/2 x squared, close squared dx. Yeah, believe it or not, these first ones in these first section, if you FOIL this and bring in the 1, you can actually do enough algebra to get this to a perfect square, which will, the square root will get rid of it. And you actually work it out by hand. But of course, that's easily 5, 6 more steps of algebra, and I don't make people do that with these calculators. Now, that's the way I had to do them in tech in the 80s, which didn't have the calculators. But yeah, with the calculators now, you can just, punch away. Anybody see or anybody want to see this punched in, or?
I just letting you know the answer is 309.3. Just
Okay.
That's from the textbook.
From the textbook, you're supposed to get 309.3. Just a second, I need to yell at my technical assistant. He's right back. He's in his room, I believe. The breakfast is ready. Yes, I am. Okay, do you want to see any more arc length problems, or are you ready for the second part of this section, which is surface area?
Area of a surface, woo.
Yes, all right.
Isn't it just adding the 2 pi rx?
It's not quite that, it brings that in, but it's not quite that simple. This is the second part of 7.4. Find surface area when revolved around the X and Y axes. It's the same curve, one-sided curve, just a top between A and B. And you're, say, around the X-axis, you want the area of the surface. This is mirroring down f of x here. And you want the area of the surface. It would be like, I don't know how many times y'all fly, or you ever been on an airplane and you looked out and you got the engine on the wings. So you got your airplane, and you know, a lot of airlines will have their engine hanging below the wing or something. So you get airline engine, look like this. And I know what you're sitting there in your airline seat and you're wondering, gee, how many gallons of paint would it take to paint that thing? Well, I am here to satisfy your incredible curiosity, because you can treat it as revolved around the x-axis, and the area around it, the surface area of it, you'd have to buy enough paint to cover the thing with paint. Okay. Yes, you're right. You mentioned the 2 pi r. When you look inside there, you see circles. Okay, but we want the circumference of the circle. And yes, it is 2 pi r, and the r equals the f of x. So that is 2 pi f of x. All right, but you take two of these circles together, and the distance between them will be the delta L, really from the arc length. That's why you do arc length first. So the actual surface area is equal to the delta L in the one dimension along the curve. I know that got to be gibberish up there, so boom, boom. Delta L along the curve times the circumference times circumference. Gone. Bad morning today. Circumference. You ever have a total brain drain? I can't even spell circumference. It's right up here. Oh my goodness. We will not be sending a tape of this class to the Teaching Hall of Fame. Okay. Well, that delta L from last section, the arc length, is a big square root of the 1 plus f prime of x squared. And your circumference is 2 pi f of x. So wave our hands and add all the pieces up, and you wind up with this formula: 2 pi to the front, a to b. Collect all the f of x's in the back of the integrals. You got an f of x. This is your radius. Big square root 1 plus f prime of x squared and dx. Now notice this is a simple universe. dx, and you're around the x-axis. So a dy will be around the y-axis. Surface area around y-axis. 2 pi, integral from a c to a d. F of y, big square root, f prime of y dy. And you saw how complicated the arc length integrals were with just this piece. You see how more complicated they are because you throw the original formula in now. And one other issue, I know this is going to break your hearts. We will only do x-axis and y-axis problems. That's all they ask about. They don't go around lines above, lines below, lines left, lines right.
Oh no.
I know, it's so terrible, doggone. But they really are just plug and chug. You don't really need a graph or picture of them.
It seems like the hardest part is just finding the derivative.
Right. So they don't really give you much practice with it either. The problems start on the next page, 482. And they really run, let's see, x-axis problems are 39 to 43. Those are x-axis problems. 45 and 47, they're y-axis problems. And 49 is back to an x-axis problem. And they all pretty much plug and chug into these two formulas. Anyone in particular that you'd like to see?
Let's do a y-axis one.
All right, y-axis problem. First one is say 45. Page 482, problem 45. A cube root of x and add 2 with 1 less than or equal to x less than or equal to 8. And this is find surface area around the y-axis. Okay, so I'm going to plug and chug into 2 pi c to d f of y, big square root 1 plus f prime of y squared dy. Okay, f of y is an x. This f prime of y is x prime. So I'm going to have to convert, solve for x. Cube root of x, add 2 for x. And I'm going to have to convert x equals 1 and x equals 8 to y values. Can you see that? If I have y equals cube root of x, add 2, I'd go y minus 2 equals cube root of x. And then I need cubed. Y minus 2 cubed is equal to x. I now need the derivative. Need x prime. Can you do it in your head? You'd get 3 down. Y minus 2 squared. Look inside for a chain rule, but it's 1. I don't have to write the 1. I just like to point it out just so you don't forget to look for it if you need it. So let's pause for station identification before I go to the next page and plug and chug all this gibberish in. Did we lose anybody?
Nope.
No. So I've converted the curve to an x curve, took its derivative. I've got, I can plug that in. I'll do the values on the next page, I guess. It's I'm out of room. So surface area, I've got 2 pi. Integral, I won't write the numbers down. It's not 1 and 8, those are x numbers. The x was y minus 2 cubed. Big square root, 1 plus, and the x prime is 3y minus 2, close, close, squared, dy. I got to find the limits. Find limits. All right, well, the x was equal to 1. The y was equal to the cube. You can see it up here. X is equal to 1. We were given between 1 and 8. The y is the cube root of x, add 2 from here, which means y is equal to the cube root of 1, add 2. Looks like that would be 3. Plug in x equals 1 into your y equation. X equals 8. You'd have, well, right under here, y is the cube root of 8. Add 2. Looks like that would be 4. Cube root of 8 is 2. Add 2, 4. This would give me 3 and 4 for y numbers. So look at that mother to punch in. That'll be a little work. Questions about that?
Nope.
Anybody want to see another one? Like a straight X?
Sure.
How about 43? 482, 43. Y is the square root of 4 minus x squared. Negative 1 less than or equal to x less than or equal to 1. Find surface area around the x-axis. We'll need a y prime. The square root's in a half power. Bring down the half. 4 minus x squared. You subtract 1, negative a half. And you look inside for the chain rule of negative 2x. Been a while maybe since you've done derivatives, so any questions about that derivative?
Nope.
Okay. I'll write down the formula we're plugging and chugging into. 2 pi a to b. I use y, that's your f of x. That's your original curve. Big square root. 1 plus y prime squared dx. Two pi then. Negative 1 to 1. The original curve is square root 4 minus x squared. Then a square root 1 plus, this is a half, 4 minus x squared to the negative a half times a negative 2x. And all of that is squared. Lost room for the dx. I believe, see how this is square root, this is square root. You can actually, I'll put this in parentheses, combine the roots, distribute this through. Notice how this might cancel this because this is on bottom. I mean, it's a lot more algebra if you want to mess with it. I believe you can actually boil it down, work it by hand, if you're willing to do the next 15 steps of algebra. Or you can figure out how to punch that monster in. Anybody want to take the time to punch away, or y'all good?
I think that we're fine.
Okay.
Especially now with the algebra. I'm good with least amount of algebra.
Okay. We're approaching 45 minutes. And that's pretty much examples of all the stuff in 7.3 and 7.4. Anybody wanting to see anything more before we end? I believe next week we finish chapter 7 with 7.5, just one section. And we'll have a test on chapter 7 the end of next week. No quiz on just on 7.5. We'll just finish 7.5 and have the test. That'll be test 2 next week. Same format as we've been having them.
And then you said the unit after that is your least favorite?
No, I don't. I get along pretty good with chapter 8. Unfortunately, students don't.
Oh no.
It's chapter 9. That's my least favorite.
Well, that's a problem for a future me.
Yes, that's coming attractions. Okay, anybody else want to say anything? We'll try very hard to stick to the same exact Zoom schedule. So again, next week, Tuesday and Friday at 9. So next one would be next Tuesday at 9. Hearing no comments or anything, I guess we'll end the meeting.
Thank you.
Okay, thank you. See you next Tuesday. Hope you can come. Have a good weekend.